Hi friends, welcome to the class of Design and Analysis of Algorithms. Now we'll see the problem of 0 by 1 knapsack by using FIFO branch and bound method. So first of all we'll see what is this 0 by 1 knapsack problem. Of course we are given a n number of objects with weights and profits where I varies from 1 to n and also a knapsack with capacity m. So we have a bag. A bag has to be filled with objects. Each object will have weight as well as profit. If you insert an object into the bag will have some weight as well as you will get some profit. So in order to add the objects you need to sum up the profit so that the total profit has to be maximized. This is actually we call it as a problem of knapsack. So the problem is we have to fill the bag with the help of n objects and the resulting profit has to be maximum. So here it is given by, that is maximizing the total profit by taking objects one by one, subjected to what is the constraint is the total weight should not exceed the capacity. The capacity of the bag is given, that is m, capital M. Let us suppose the capital M value is 20, that means let us suppose 20 kgs. So whenever you are placing the objects, the total weight of all the objects should not exceed the total weight, that is 20 kgs. Like this you can consider. And I varies from 1 to n, that is number of objects, and xi, this is 0 by 1 knapsack problem. So if I put xi is equals 0 means that object you are not including. If I put xi equals to 1 means the object you can include. So there is no question of inserting fraction of an object here. So this is a knapsack problem statement. Now we will solve this 0 by 1 knapsack problem by using FIFO branch and bound. So what is this FIFO branch and bound? So you can see my previous lecture, that is LC branch and bound. So you can find what is that branch and bound, and what is this FIFO means first in first out. We will see what is this first in first out concept and what is this is a procedure we follow, and we will solve the problem of knapsack. So let us consider the example. I am taking 4 objects here, so with profits like this and weights are like this, and of course I'll take the capacity m as 15, the bag capacity. So here we'll solve it by FIFO branch and bound. So what is this FIFO branch and bound? So draw a state space tree and set upper equals to infinity. So I'll create a node here, that is node 1, and I want to set upper. I'll take one variable upper where the value is infinity. Now compute c cap of x and u of x for each node. So how to find this c cap of x and u of x? Here for each node I need to find, so I am taking here c cap of 1, u of 1. So how to find for u of 1? So it is a where you can consider only 0 by 1, that is don't include the fractional part, whereas c cap of 1 you can include the fractional part. Like this you can consider. So if you consider like this, for if I include the first object here, 2 is the weight and the profit is 10. Now I can include the next object also because the capacity is 15. So 4 and the profit is 10, and next I can include the third object, that is the profit is 12. Now if you consider 12 and if I want to include the last object, so it is exceeding the capacity, that is 15. So totally that is 12 plus 9, 21, which is exceeding 15. So now I want to include, and whatever the profit I am getting, that is 32, I'll write here with negative sign. And fractional part I can consider for c cap, no? So that's why. So 12 and remaining is 3 I require out of 9. So here the profit is also 3 by 9 into 18. So I'll get extra as 6, that is minus 38 here. Now the next step is, of course you need to find here if u of x is minimum, then upper will set to u of x. So here u upper value is infinity, u of 1 is minus 32. So I'll make this upper as minus 32. So here it is then, not them. Now c cap of x is greater than upper, kill the node. So check out what is c cap of minus 38 is greater than minus 32. No, so that's why don't kill the node. And next live node becomes c node. See how the nodes are coming in the order, in that order only you need to consider the next E node. So that's why here we call it as FIFO branch and bound. So first the node is coming 1, and for that I am generating 2 and 3 here. So the next nodes are 2 and 3. 1 I generated, so next E node will be 2. For that I need to generate, this is x1 equals to 1, this is x1 equals to 0. That means x1 you need to include, here x1 you don't include. So we'll get the values, that means x1 must be included. So how we are doing, you want to get the clarity, you check my previous video, that is LC branch and bound for 0/1 knapsack problem. So here I am writing the values directly, that is C cap of 2 U of 2 which is equals to minus 32. Here I'll get here C cap of 3 means you don't include x1 now. So I'll start from 4 only, 4, 6 I'll include, that is 10 plus 12. If I want to include this, I cannot include because total 19 which is exceeding. So only 4 plus 6 which is U of 3 is minus 22, and C cap of, I can include the fractional part. So this will become minus 32. Why? Because that is we need to write from here. Why? Because x1 is 0, don't include x1. So 4 plus 6 is 10, that is 22, plus here how much require is 5 out of 9, that is here also. So like this, if you consider 5 into 2 10, that is totally minus 32 you will get here. So in this what we need to consider here, u of, you can see here, if u of x is minimum, then upper you need to consider. So minus 32 minus 22, which is the minimum, minus 32 minus 32 minus 32 here. So don't update upper. If you get the value here less than this, then you update the upper. So next step is, if C cap of x is greater than upper, kill the node. So minus 38 is greater than minus 32, no. Minus 32 is greater than minus 32, no. So next E node will become 2. So here you can see the statement, that's step number 6, next live node. What is the next live node? 2 is the next live node. So I'll have to generate for 2, that is for 4 and 5. So 2 I'll generate. So for 2 here, 4 and 5 I have to generate, and here x2 equals to 1, here x2 equals to 0 you have to write. So this is C cap of 4 which is equals to, what is that? Here you need to include x1 and x2. Of course I'll get the same thing there, minus 38. And what about u of 4? Of course the same thing, you have to include x1 and x2. I have, of course I included, this is optional, so I included for u of 4 without fraction, for C cap of 4 with fraction. So for this one I'm writing here C cap of 5, wow, it is equals to, and u of 5 I am writing here. So both are u of 5, what is that? x1 must be included, x2 you need to ignore. So 2 plus 6 plus, you can write like this. So first I need to include 2. If I include 2, the profit is 10. Next ignore second one, so 6 I have to write. So here is 12. So 8 plus 9 17, which is exceeding, that's why this is minus 22. And C cap of, I can include the remaining part, 7 out of 9. So 7 out of 9 which is of course 18. So 7 into 2 14, which is 14 plus 22 which is minus 36. Now for 2 I generated, what might be the next E node? 3. So of course you can check this, minus 32 minus 22, minimum is minus 32, that is as it is. And next you need to consider next E node, which is C cap of, that is third node, where you need to check for minus 32 is greater than minus 32. Okay, don't kill and take this node. So for 3, if I generate 6 and 7, so 6 and 7 I need to write here. So x2 equals to 1, x2 equals to 0. Here x1 equals 0 and x2 equals to 1. That means include second, don't include first one. So that means, so I need to start from here only. 4 plus 6, that is 10, and here 22. Don't include this one because it is exceeding. That's why, what is this u of 6 value? U of 6 value will become is minus 22 here. What about C cap of 6 here if you consider? So don't include the first object, no. So 4 plus 6, then 5 we require in this, 5 out of 9. So here you will get 5 out of 9. This is 10, totally minus 32 you will get here. So this one, if you consider u of 7 and c cap of 7, if you see u of 7, that means x1 x2 both should not be included. That means these two should not be included. Only 6 plus 9, which is 15, and 12 plus 18, 30. So 6 plus 9, 15. So there is no need of fractional part. So you will get minus 30 here, here minus 30. If you see minus 32, minus 30, minimum is minus 32, here is also minus. Don't update, and u of is also c cap of x is greater than upper, no, here also no. So that's why no need to kill the nodes. So after that, the next e node is 4. For 4 you need to generate 8, 9. So for 4, if I generate 8, 9 here, so 8, 9 here, this value will become, you can see here, so u of 8, so x3 equals to 1, x3 is 0 here. So if I take x3 equals to 1, that means first, second and third object must be included. 2 plus 4 plus 6 I'll include, and of course fourth is optional. So here I'll get the same thing, minus 32, here minus 38. So what about this one? So here first, second objects must be included, third object don't include. That means 2 plus 4 I include, and third must not be taken. So I'll take 9. 2 plus 4 plus 9. So total 15. Exactly. It is filling the bag. So 10 plus 10 plus 18. Totally minus 38. So here c cap of 9 is minus 38. U of 9 is also minus 38. Now if I consider minus 32, minus 38, which is the minimum, minus 38. Minus 38, if you observe with minus 32, so now it will be updated. So now after updating, what is the next e node? 5. If you take for 5, what is c cap of value? Minus 36. Minus 36 is greater than minus 38. Yes, true. That's why kill this node. You can see in our steps also, if c cap of x is greater than upper, kill the node x. So I am checking here for 5, node 5, minus 36 is greater than upper. That's why I am killing the node 5 without generating its children. Now if you go to the next e node 6, what is the c cap of 6? Minus 32. It is also greater than upper. So killing the node 6 without generating its children. 7 is also. So minus 30, of course greater. This one is also. So now if I go for this one, minus 38 is greater than minus 38? No. So I can generate for this one. And if I go with this one, what happens here? x4 equals to 1. So that means 1, 2, 3, 4. All object has to include. So this is infeasible. If I include all the objects, definitely bag exceeds the capacity. So here if I go with this, of course this is, if I generate 10 and 11, for 11, what is c cap of 11 if you consider, and u of 11 means this is x4 equals to 0. That means first 3 you include and don't include the fourth one. So you ignore this one. 2 plus 4 plus 6 here, 10 plus 10 plus 12, which is minus 32. Here is also minus 32. Now if I observe, c cap of x is minus 32. C cap of 11 is greater than upper. Kill this node. So 11th is also will be killed afterwards. Anyway, I need to generate for the next 8 I generated. After that 9 if I consider, so I'll get the answer here. So if I give here x4 equals to 1, I'll get the node here 12. Here I'll get the node 13. For node 12, so for node 12 if I consider, x1 x2 has to be included, x3 not included, x4 has to be included. So ignore third one. I'll get 2 plus 4 plus 9, which is 38. So here c cap of 12 is minus 38. U of 12 is also minus 38. And if you consider here for 13, u of 13 is, what is u of 13 here? So I need to include x1, x2 has to include, don't include x3 and x4. Here x4 is 0. So only you need to include first two. 2 plus 4 is 6, 10 plus 10, 20. If I consider this one, so minus 20 here you will get, here c cap of 13 minus 20. So minus 20 is, if I consider here minus 38 is greater than minus 38, no. minus 20 is greater than minus 38. Yes, kill the node 13. So here 13 will be killed, 11 will be killed, and what about 10? Next one, if I consider 10 is infeasible, and finally 12 is our answer node. So from 12 if I go with the path, so 12 to node 9, 9 to node 4, 4 to node 2, 2 to 1. If I consider 1 to 2, so x1 equals to 1. So 2 to 4, x2 equals to 1. So 4 to 9, x3 equals to 0. So 9 to 12, x4 equals to 1. So this is our answer, that is x1. You are including first, second and fourth object, so that the weight will be 2 plus 4 plus 9, which is 15, not exceeding the capacity, and profit is 10 plus 10 plus 18, 38 is our profit. Like this we are finding the problem of 0 by 1 knapsack using FIFO branch and bound, that is first in first out. So in our example we are generating the nodes, and in that nodes which node we are considering based on which comes first. So that's why our E node will be the one which comes first. That's why here we call it as FIFO branch and bound problem. Thank you.